So this is set up for direct loading test. In name itself, we are going to apply the direct load. The procedure is, so in case of direct loading test, this is prime mover, right? This is field winding, in which to which we are going to apply the 220 volt DC. Generally 220 volt DC supply is applied to the field winding, and the field current is near about 1 ampere, 1 to 1.2 ampere. Voltage regulation is nothing but the change in terminal voltage from no load to full load, keeping field current and speed constant, right, in terms of rated voltage. Okay, now let us see. This diagram is showing a circuit diagram for direct loading test. For calculation of regulation, it is used for the alternator which is having capacity up to 5 kVA and less. Initially, this prime mover is started. Once it is started, the field excitation is gradually increased. We have not connected any load to the alternator armature. Once gradually we are increasing the field current, the EMF start building in the armature. Once we have got rated voltage at these 2 points, we can close this switch. This is triple pole switch. Okay, so gradually we are going to increase the load, right? We have to increase the load, and with different loading condition, we have to take the readings by varying the field and speed. Speed should be constant. So I will just write down the steps to calculate the direct loading test or perform the direct loading test. We have to drive the alternator. Alternator is driven at a rated speed and terminal voltage. Okay, second step will be terminal voltage is adjusted to rated value by increasing excitation. Third step, load is applied to alternator and varied. So ammeter reads rated armature current. Then fourth will be, while increasing the load, there may be drop in the terminal voltage, right? So the drop in terminal voltage, how to adjust the drop? By increasing the excitation and maintaining constant speed. So the drop in terminal voltage due to armature current or due to armature reaction, we can say, can be compensated by increasing field excitation and adjust terminal voltage rated value. So for every reading, we have to do this. Okay, if there is a drop in a voltage, we have to adjust the excitation to get the rated terminal voltage. Okay, so once this procedure is done, what is voltage regulation? Change in terminal voltage from no load to full load. But in this case, we are just increasing the load till we are getting the rated armature current. Okay, so once we got the value of rated armature current, we have to note it down. Okay, once we got the value, we have to throw off the switch. Okay, so once this switch is thrown off, what will happen? There may be increase in this voltage. This voltage will get increased beyond the rated value. Fourth step, load is thrown off, and for same excitation, open circuit induced EMF is measured. Okay, so once we got this reading, we can find out the voltage regulation. R is equal to EPH minus Vt upon Vt into 100. So we'll get the value of EPH and Vt. By using this formula, we can measure the voltage regulation. So this is all about direct loading test.